This is going to be part 2 of our pair of NuTone 2016s, and I decided that I'm going to work on the one from 1961 first. These videos are not going to be super detailed, and I'm not going to be moving the camera around and doing that kind of stuff much, because the goal here is I have to fix these more than anything else, and it takes a lot of time to do that. So I'm going to just record certain parts of it as I go along to show you the kind of things that maybe you will find interesting. So first thing we're going to do is we're going to disassemble this, because we need to take the faceplate off and put it aside. So I removed the knobs just as a point of interest. These knobs, which were used in the late 50s and early 60s on NuTone intercoms, these knobs, these are the same exact knobs that are used on Macintosh amplifiers from back in the day. So they're very stylish knobs. Spare no expense. So the faceplate is held onto the chassis with the nuts on the back of the shafts, and you just need to loosen them and unscrew them. Best thing to do that with is just a pair of pliers. You want to be really careful when you do that you don't grind the pliers against the anodized faceplate, because you will scratch it and gouge off the anodization, I guess. And if you do that, there's no real way to fix it. Once it's scraped, it's scraped. So these came off easily. I'm going to guess this has been taken apart before. So once you do that, you can take the chassis off the faceplate. There are these cork gaskets that go here and here, and they need to be glued back on. It's to seal up the unit as far as I know. And you can see on the back side where it's not, well, maybe you can see, it's all shiny. It's the anodization, the copper look is much better. It's faded on this side. I guess that's what happens to them. So I'm going to put this aside and continue on. The next thing to do is remove the grill over the speaker here, and it's held on with these little push clip things. That's a technical term, push clip thing. And all you do is you take a very small flat screwdriver and you just pop them up and they pop off. You want to be careful when you do this that you don't put the screwdriver this way and leverage it, because you'll smash the metal grill work and then it'll look bad. You want to kind of do it in the direction that you won't see it when you put the faceplate back on. There are 6 of these, and you just carefully try to get your little screwdriver underneath them, and once they start to come up, they come off pretty easily, like that. And like that, and then this will lift off. There is this sort of papery, cardboardy piece that goes underneath it to block off the slots in the grill. See, slots in the grill, you can see through it. And of course this gets put aside because we don't want this to get damaged. And there we have our exposed chassis. Now that we've got it taken apart, the next thing we do, and this is about as far as you can disassemble this. I did take the cover off the bottom of the chassis, but other than that, taking it apart any more than this is not practical to do. But one of the things you do have to do is you have to cover up the front of the speaker cone, because if you don't, it will get damaged. And parts for these are non-existent. The only source for parts nowadays are from donor units, and that would be a shame. So I'm just going to use a piece of cardboard, cut it the appropriate size, and I'm going to tape it over the grill. We do have to deal with the broken dial glass, but that'll be like one of the last things that gets taken care of, because you don't want it, it's not critical to the repair at the moment, and we don't want it to get broken again. Like this. If you don't cover this up, I can almost guarantee you that at some point you're going to lean on it, or press on it, or your screwdriver is going to slip, and you're going to puncture a hole in it, and then maybe you can fix it, maybe you can't, but it's certainly better just to cover it up to start with, so now it's protected. I'll be back. The very first thing we're going to start with is replacing this. This is a multi-section can capacitor. It's an aluminum can, has a cardboard cover on it to insulate it. The cardboard cover comes off. It's an aluminum multi-section can capacitor. Inside of it, there are the equivalent of 3 capacitors. We have, I think you can see that, we have 80 microfarad at 200 volts, 40 at 200, and 40 at 200. That's the 3 capacitors. This is 60 years old and probably of questionable quality even when it was new by today's standards. This actually has a code date on it. This was actually made on the 25th week of 1960. So this was made about a year before this was assembled. So this has been around a long time. These always need to be replaced. These fail, and when they fail, they begin to turn into big giant resistors. That's where most of the AC hum comes from systems like this as they get old. If they fail completely, you'll get the magic smoke come out. So this is difficult to do. Fortunately, nowadays, there is a company that makes replacements, and this replacement is 80. It's higher voltage. It's 250 volts nowadays, which gives it longer life. So it's 80, 250, 40, 250, 40, 250. It comes with its own mounting plate like that. So what I have to do is I have to remove this. Let me get rid of this for now. I have to remove this from the set, and if you look on the bottom, it's right there. That's the bottom of it. Insulating plate is riveted to the chassis, so that has to be the wire. All these components have to be disconnected from it so the can be removed. Then I have to change the insulator, then reattach all that. So there are literally, seems like 1 million connections. It's not really a million. It's more like 24, I think, or 22 little connections that go onto the tabs on the bottom of the capacitor. There's the 3 tabs in the middle, 1 for each capacitor, and then these 3 on the outside are the, in this case, ground of the can itself, and that's why the can has a cardboard insulator on it, because there's voltage on the can, and you don't want to have somebody lean their hand on it like this when it's live, which you should never do, because you'll get a shock and it'll hurt a lot. So I'm going to prepare to do this, and when I get closer, I'll be back. All right, I'm back. A bunch of time has passed, and we're ready to remove our can capacitor. I guess we should put the cardboard sleeve back on it. It's got this tarry stuff on the outside of the aluminum can that holds the cardboard on, and it gets all over your fingers, and it's kind of sticky. So there's the old one, and you can see the new one is smaller. Same diameter, just shorter, because it's modern, I guess. That's the way they make it. They only offer them in certain sizes. It's the diameter that matters the most because it has to fit in here. Unless, of course, you have a height requirement because there's other stuff in the way, but that'll work out just fine. So I disconnected the 1 million leads, or perhaps it's only 22, on the bottom of the unit right here. And what I did was, the way I do this is, because you have to get everything back in exactly the same spot. So what I did was I made one of my diagrams. And while this may seem jumbled to you, it makes perfect sense to me because I'm the one that drew it. Basically what we have here is the outline of the insulator, this piece. It shows the 3 tabs that come through the can to hold it to the insulator. Those are also connection points. The 3 tabs that come out of the bottom of the capacitor, that's the copper colored ones in the center. The outside ones are the ones that go through the insulator. And then I carefully drew in each individual wire as it was disconnected. So for instance, this one, and I also marked of the 3 tabs, because one of these tabs is, let's see, we'll put it, it sits in there this way. So this is the 80, that's a 40, that's a 40. And the way these kind of capacitors are marked is this one, the 80 is a square, and this one over here, the 40 is a triangle, and this one has no mark, so that's just a dash mark. So what I did was I wrote in here, you got 80, 40, and 40 in red. Up here, I made a legend just to remind me The more information you put as you do this, the easier it is to remember. Square is 80, triangle is 40, no mark is 40. As I disconnected each wire, I drew it in just roughly the direction that it goes in under the chassis. And as I disconnected each wire, I put a wire marker on it. Wire markers are these. They're little self-stick, sort of fabric-y adhesive labels that you can wrap around wire to number them. For instance, I started with 3 because that was the pad I already had open. So this one is red line number 3. It's a red wire, it's number 3. And then from this one, here's another red wire, it's number 7. And this one is a red wire, number 4 there, and so on, 5, and so on. I marked all of those. I did draw in here between these two connections, there's a resistor, it's a 2.7K, and I wrote up here, made a legend 2.7K, which is red, violet, red. I did the color coding just because that's visually the way I like to do it. And then there was another resistor that comes off this one. This is 180, and there's another one that goes down here that's 220K, and so on and so on. So the individual, all the wires on the 3 tabs in the center are red wires. So they were all removed individually and then numbered. And then on the CAN connections, on the tabs on the outside, on this tab, there are 3 white wires and a resistor. And on this one, there are 5 white wires. The white wires go to different places, but they're all the same connection. If you do a continuity check between here and here, it's the same because it's all the negative connections on the CAN. I didn't number all of those because I know there's 5 white wires that come off this one, and they all come from sort of the left-hand side of the set. And this one has 3 white wires and the resistor. The resistor goes up to a terminal, I think it's on one of the tube sockets, so it's just long enough to reach that. But these all sort of go off in this direction, so it's kind of obvious what to do. The other thing that's important about doing something like this is once you start, now is not the time to stop. So you've got everything marked, you've got everything sort of pushed off to the side to make it all make sense to you. And now is not the time to go play soccer with your kids. Now is the time that you sit here and put it back together because it's fresh in your mind. And that's what I'm going to do next. The nice thing about this is, let me sort of brush this off a little bit because it's got some crud on it, is while the company that made this included one of these, which is very nice. Fortunately, the size of this is the same size as the one that's already in there, and I can simply take this and pop it in like that. And it fits exactly because they're the same size. So I don't have to change this. Changing this it's not terribly difficult to do, but it's one more thing that you're horsing around with. The insulator, the original one, is pop riveted sort of into the chassis. To change it, you have to drill out the rivets carefully so you don't drill through something in the bottom, which there's lots of stuff in the way, and then you'd have to, I can't really re-rivet it, that's hard to do. So you'd have to use little machine screws with nuts and washers, and it's just more to do. So it's nice that they're the same size, because they know their capacitors are being used to replace original capacitors. These are sort of a standard form factor, and so that just makes it a little bit easier. So now I'm going to put this in place, and then I'm going to sit here and hook up the 1 million connections, or maybe it's only 22. I'll be back. A lot more time has passed, and our new multi-section can capacitor is now in place. If you look on the bottom, you can see the 1 million connections have been restored. And if you look really carefully, you can see all the little number tags on all of the wires as I labeled them, made the diagram to take the old one out. They were all very carefully put back into place in their proper connections. I did it in exactly the reverse order as I took the other one out, because that's what always makes the most sense to me. There were a couple of them that, a lot of the leads and point-to-point wiring, you have these little cloth tubes that cover up the wire leads of the components, and of course when you move things around, the cloth leads or the cloth tubes are like 60 years old and they fall apart and crumble. And for instance, this resistor right here, the one that is, I think it's red, yellow, the lead on this side, the cloth tube fell apart, so I do have some This is modern. It's woven cloth tube just like the other, but it's silicone impregnated, so it's very flexible and it won't just fall apart, and it's a good insulator. And so I replaced some of those and very carefully made sure everything went back to its correct connection. It probably quadruple checked it all. The other thing you have to be really careful on this is because you have a lot of wires that crisscross over and under other things. And so you want to make sure that nothing is pressing on something else, because, for instance, the connections where all the white wires are, those are the outside of the can. It's the ground and it's high voltage, and some of the red wires sort of loop around and go across those, and you just don't want things pressing on other things because the insulation on the wires is 60 years old and you don't want it to rub through and those kind of things. So you try to keep everything positioned correctly. And I think it's good. I'm going to leave the wire markers on the red wires until I complete the rebuild and power it up to make sure it all works, just in case there's any mistakes. And that way I remember where all the wires were attached and I don't have to do all of that again. So the next step now is I have to replace some of the small filter capacitors and other things on the bottom of the set. That in some respects is simpler, but still a lot to do. More time has passed and we've made good progress. The last time I had gotten the multi-section can capacitor installed, and now I've installed the 3 new film caps, which are here, here, and here. And there is one single little electrolytic right here. It's kind of hard to see because it's black, and those are all now in place. The next part of the project is the most exciting part of the project, which is, no, it's not powering it up, because so far I have not powered this unit up at all. When you work on vacuum tube sets, you should not power things up until things are fixed, because that's just dangerous sometimes. Things can suddenly go poof and the cloud smoke comes out and then you'll be really sad. I know the fellow that sent this to me, he actually had it powered up for some purpose or another, didn't really get into why, but it had so many bad tubes and things, it probably was pointless to do that because the tubes were bad. Anyway, the next part of the project, which is the exciting part, is tube sets have lots and lots and lots of resistors in them. And it's necessary to go through and check and measure each and every resistor individually to make sure that it's still within specifications. Resistors in tube sets primarily are there to adjust voltages to things. And if they're bad or out of spec, then the voltages will be wrong and the set won't work the way it's supposed to. There is no easy way around it. It's just a matter of going through it. You start at one end and you very methodically go through and measure every single resistor, and you compare it to what the bands on the resistor tell you it's supposed to be rated for. You cannot rely on the schematic in the service manual because parts like resistors change throughout production, and if they don't update the schematic, which they don't typically do, what it says in the schematic will be wrong. So by default, unless you know for a fact based on what you see that someone has replaced parts in a set, you go with what's in the set. If it's got a 220k ohm resistor in place, that's what it should be. Never mind what the schematic says, because at some point they decided to make a change and that's what you've got in the set. That's for tomorrow because I'm out of time for today. So this is the end of part 2 and the next one will be part 3. See ya. Oh wait, like, subscribe, all that good stuff. Keep an eye open for the next part 3 video, which will be coming out soon.